Let's go over some interesting information about acids and bases. We're starting with acids. Well, first of all, what's an acid anyway? Well, it happens to be a group of compounds that when you throw them in water, you end up with hydrogen ions separate from the rest of the molecule. If you take a look here at your acids, every single one of them, you have H on the left-hand side of the formula. The hydrogen ion separates from the anion, the negative ion, providing hydrogen ions in solution. As a matter of fact, that's one of the definitions for an acid. Arrhenius said many years ago that an acid provides hydrogen ions as the only positive or cations in solution. For bases, let's check that out. What is a base? Bases are actually salts. They're ionically bonded, where acids are covalently bonded. And you notice for these first three on this table, these two tables come from the New York State Chemistry Regents exam, you have a metal and OH. Now, OH you might recognize, that of course is a polyatomic ion known as hydroxide. So anytime I see a metal and OH, not only is it a salt or an ionic compound, it is also called a base. Well, why are these bases? Well, you put them in water, and now the cation, whatever the metal ion is, separates from the hydroxide, and you end up with hydroxide ions in solution as your only negative or anions. That is Arrhenius's definition of a base. We do have an exception here, and that is ammonia. Now, ammonia, the formula is NH3. It does not follow Arrhenius's theory for a base. However, ammonia and water does form ammonium hydroxide, NH4OH. In order to explain that, another theory was developed known as the Bronsted-Lowry theory. For New York State, they just call it the other theory that explains ammonium hydroxide. So for now, don't worry about it. Just know ammonia is a base. Let's go back up to acids because there's one more thing that we need to go over. The naming of bases then is covered already when we're naming ionic compounds. However, for acids, let's take a look at the name. Every single one of these you know is an acid because, of course, the word acid is in the name. But some have hydro in front with an ic. Others just have an ic in front of the acid, and others have what's known as an us in front of the acid. Well, what gives here? Why are the endings and sometimes the prefixes different? Well, let's check that out right now. The table we just left is known as common acids, but it's not all of the acids. We're here to take a look at the naming of any acid. Binary acids mean you have one other element besides hydrogen in the formula, and that has the format here of this hydro and then the ic acid. We saw already on the reference table, HCl is known as hydrochloric acid. All I'm doing here is putting in the prefix for the other nonmetal right into the name. That means HBr is known as hydrobromic acid, and H2S, still binary, two different elements, even though there's two hydrogens for every one sulfur, is hydrosulfuric acid. Here they are spelled out for you, where you see that I placed in the bromic and the sulfuric. One other thing before we get to ternary acids. When these are in the gas phase, for example, HCl, that's known as hydrogen chloride. But in order to have an acid, remember it has to be in water. That's when the separation is going to occur. And that's why in parentheses on the reference table, and for any acid, AQ is in parentheses. Hydrogen chloride, hydrogen bromide, and hydrogen sulfide, those are gases. But when you put them in water, you get hydrochloric acid, hydrobromic acid, and hydrosulfuric acid. Anytime from now on, when you see a binary acid, hydro goes in front, you put ic at the end, and then, of course, the word acid. let's move on to ternary. These acids have a polyatomic ion along with H. We see SO3 and we see SO4. Now, over here, I have us goes to ite and ick goes to 8. In other words, SO3 2 minus is the polyatomic ion sulfite. But when you have hydrogen and sulfite, you have what's known as sulfurous acid. For sulfate, SO4 2 minus, now, of course, instead of it being sulfate with hydrogen, it's known as sulfuric acid. The ending of the poly, us goes to ite and it goes to 8. Quick story, when I was in high school, I had Mr. Carr as my chem teacher. Mr. Carr had taught at my high school, I think when he retired, something like 50 years. Amazing. And he was the only guy in the 70s that I knew that had a crew cut, and every day, instead of wearing a regular tie, he had his bow tie. And he would walk around the room and bark things out, literally. And one of the things he would do is say, us, I, ick, 8, us, I, ick, 8. And I had no clue as a high school student what in the heck he was talking about. It was only when I got to college and we were studying acids, I realized it was just his way of letting us know what the names are. Okay, that I goes with us and 8 goes with ick. Here it is, the us acid and the ick acid. I'm going to put a few more below. Let's see how you do. Here are 4 acids, and I gave you here the polyatomic ions and the names, but when they're bonded with hydrogen, of course, and they're in water, they're acids. The hydrogen ion is going to separate from the polyatomic. Take the polyatomic names, pause the video, and see if you can't name these as acids. Okay, we are back. Let's take a look at what the answers are. Remember your usite ick 8, that your hypochlorite is going to become hypochlorous acid, the OUS ending. And then we have, of course, chlorite. Ite becomes the us ending. For chlorate, the ATE, it's ick. And then perchlorate is perchloric. That's how you name acids. Keep working hard. Good luck. Always do your best.